Ah, okay, good afternoon, Anshuman and Vinod Kumar. All right. So, this is the English. Raju, Prashant, Venkatadri, Venkatadri Swami. So, uh, we have finished everything, especially blanking and punching. And the remaining topic of bulk forming. Moninathan. Now, today is the last topic of metal forming. There we will discuss remaining sheet metal forming. Remaining sheet metal forming techniques. Babu again, I was discussing with Babu 2 minutes before on Telegram live. Actually, I want to help students, my dear students. Actually, so although nobody does, but I still do it. Actually, every week it's my commitment to interact with the students. So because 5 o'clock I have class, so I had thought of that's the reason I was interacting. Actually, I'm not paid for all these things. Okay, na? But it's my Sunday. Nobody takes class. I take. Then I will discuss powder metallurgy. Powder metallurgy. And we will do lots of questions. We will do lots of questions. That is our plan today. Let us see. It's a daytime, so there is no problem at all. My brief resume, everybody knows about it, and Telegram channel, everybody knows about it. First topic is deep drawing. We are discussing remaining sheet metal forming processes. Next is deep drawing. Suppose this is the die. This is sheet. Over the sheet, there is a blank holder. and then there is a punch. It's a punch. Now, yesterday, whatever I discussed, there was a share on the punch, share on the dice. But we don't have share. In fact, we have curvature. This is the die curvature. And it's approximately 10 times the sheet thickness. P is the sheet thickness. There is no shear. In place of shear, there is a curvature. Punch corner radius, punch curvature. It is approximately 5 to 6 times the sheet thickness. Yesterday, I discussed with you that sufficient pressure is applied on the blank holder so that sheet doesn't slip. But here the situation is totally different. Blank holding pressure is approximately 2% of the yield strength of material. Approximately 2% of the yield strength of the material. Under these circumstances, what will happen? Sheet will slip between the blank holder and the die. And come out in the form of a cup. So a sheet blank, that is a diameter, we converted into a cup of a small d diameter and h is the height. This process is called deep drawing. This process is called deep drawing. Another sheet metal forming operation. In automobile, 40 to 50% of the engine parts are produced by deep drawing process. Note down, I will dictate one sentence. Once you finish drawing and all that, let me know in the chat box, I will dictate. Write down. Today there are no complications. There are no complications today. Deep drawing is a process of deep drawing is a process of Acha, Chandu. Chandu, you were missing last 2-3 days. You were missing last 2-3 days. Deep drawing is a process of converting circular blanks into cup-shaped components. Okay. Now, any unknown parameter can be calculated by equating surface area. What is the surface area here? Pi by 4 d square is equals to pi by 4 d square plus phi dh. So by equating surface area, yeah, metallic glasses katori, Raju ban gaya gentleman. Yeah, you are correct. Raju ban gaya gentleman. Equating the surface area. Copy. Raju ban gaya gentleman. Okay, so dear students, generally in the gate, most of the answer will come from this. But there are some test series created by some people. In the options, they will give a very minor difference. 20.88, 20.92, 21.1. There is a very less difference. It means they are equating the volume. If the option there are very slight differences, it means they are equating volume. So this is the blank. P is the thickness of the blank. This we are converting into a cup. Cup diameter is D. Height is H. And of course, here we are taking an assumption that the thickness is uniform throughout. But thickness will not be uniform throughout. If you cut this cup, see the thickness variation will be like this. Cup bottom thickness will be same to the sheet thickness. And the punch corner radius, there will be thickness will be less than sheet thickness. There is a necking. and in the cup wall, it will be thicker. You know what is the reason? The reason is at the cup bottom, no stresses are appearing. No stresses, no stresses are appearing at the cup bottom. To deform the material, punch is applying the maximum load in this region. Punch is applying the maximum load in this region. So deformation of material will be maximum in this region. So necking. And why the thickening takes place? This is the intermediate stage of the cup formation. This is called cup bottom. This is called wall. And this is called flange. No stress is here, cup bottom. In the wall region, uniaxial stretching. Uniaxial stretching. In the flange region, this is the elevation. If you see the plan, this is also flange. If you take one element, there will be radial tensile stresses and compressive hoop stresses. Radial tensile stresses and compressive hoop stresses. For example, suppose this is a sheet. Now I am trying to deform it. See, sheet is getting folded. Why the sheet is getting folded? Because of compressive hoop stresses. Because of compressive hoop stresses. So if we do not apply the blank holding pressure, 2% of the yield strength. Why we apply blank holding pressure? To suppress the wrinkling. Otherwise, if you don't suppress, sheet will fold and the wrinkle will appear on the drawn cup. Wrinkle will appear on the drawn cup. Wrinkling means sikodna in Hindi. So because of compressive hoop stresses, wall will become thicker because material is drawing in, so wall will become thicker. So cup will never have a uniform thickness. But in equating the volume, we are assuming that thickness is uniform. So equate the volume. What is the volume here? Pi by 4 d square t. Now this will be d plus t. And this is a d plus 2t. So first of all, what is the volume of this? Pi by 4 d plus 2t square into t. Now plus volume of these vertical things. Pi d t into h. By equating the volume, also you can calculate the unknown, but here also there is an assumption that there is no variation in the thickness. Okay? Copy, I want to dictate few sentences here. Now you can continue, Abdullah. It's a very easy thing. You are 20 minutes late, no problem at all. It's an easy topic, so there is no issue. Whenever it is over, please let me know in the chat box. Ah, Abdullah, there is no problem. Okay, write down. Ah. Write down. In the flange region, in the flange region, there are compressive hoop stresses and radial tensile stresses. Compressive hoop stresses and radial tensile stresses, due to which there will be thickening in the wall. Due to which there will be thickening in the wall. Next point. Next point. Since the maximum load punch is applying, in the punch corner region of the drawn curve, that is the reason knacking will appear. That is the reason knacking will appear in that region. Knacking will appear in that region. Next point. While equating the volume, we are assuming that there is no variation in the sheet thickness. Okay. Suppose this is the blank. And this is the drawn cup. Okay. This ratio is called draw ratio. When draw ratio is high, knacking will be more. Knacking at the punch corner will be more. When the draw ratio exceeds beyond a certain diameter, when the draw ratio exceeds beyond a certain limit, fracture will appear at the cup bottom. Can you see the Telegram channel? Can you see the Telegram channel? Defect number 7 and 8. See the Telegram channel? I have sent the photograph. Defect number 7 and 8. So why this fracture appears at the cup bottom? Because we have exceeded the drawing limit. We have exceeded the drawing limit. And the wrinkling you see, defect number 2. Why this wrinkling appears? Because of insufficient blank holding pressure. Because of insufficient blank holding pressure. You are able to see? Just confirm in the chat box whether you are able to see these things. Confirm in the chat box. And things are clear? Confirm in the chat box if the things are clear. Okay. Now, the maximum diameter blank that can be drawn safely without any fracture. The maximum diameter of blank that can be drawn safely without any fracture to the cup diameter is called limiting draw ratio. Limiting draw ratio or LDR, and this LDR is the property of material. This LDR is the property of material, and LDR is nothing but e raised to power eta beta for any material. Eta is efficiency, and when nothing is given, take it as 1. And beta is nothing but under root r plus 1 by 2. And what is r? Strain ratio. This I discussed with you day before yesterday. Width strain to the thickness strain. Langford parameter. Copy. I will dictate one sentence here. Copy. It's a easy only. There are no complications today. Take these things seriously, because I think most of you are studying these things first time. Most of you are studying these things first time. Uh, yeah, Raju, why not? Draw ratio increases, punch load or drawing force will increase. And the larger is the drawing force, necking here, necking will be more. And the moment necking reaches a particular value, there will be fracture. Okay, Raju? Right on? Upon increasing the draw ratio, upon increasing the draw ratio, punch loads will increase. Punch loads will increase. This will increase the extent of necking. This will increase the extent of necking at the punch corner. At the punch corner. Will stop. The movement blank diameter, the movement blank diameter exceeds beyond a certain value, exceeds beyond a certain value, fracture will appear at the cup bottom. Fracture will appear at the cup bottom. Okay? Suppose I want to produce deeper cups. Because of LDR, LDR is the property of any material. For aluminum, it is approximately 1.8, and steel it is approximately 2.3. It's a property of material. Suppose I want to produce a deeper cups, for example, beverage can, Pepsi, Coca-Cola, tuck, that can. It's very deep can, it's aluminum. If we want to produce deeper cups, we perform a redrawing. Redrawing operation. What is a redrawing? Redrawing is drawing already drawn cup. Blank holder will be in this shape. So drawing already drawn cup is a redrawing operation. So deeper and deeper cups can be produced. So this beverage can, like Sprite or can you see the can, beverage can? I think you must be taking na, like tuck, like tashan, tashan ka jashan. The same can, It is produced by 3 redrawing stages. 3 redrawing stages, the can is formed. But between the two redrawing stages, if the draw ratio is close to LDR, rings will appear in the drawn cup. The ring will, this defect is called step ring. It means at the previous neck position, there is a ring. Defect number 3. Defect number 3. Check in the photograph, defect number 3. So if the step rings are appearing, what is the remedy? Decrease the draw ratio between the two redrawing stages. Beverage can is produced in 3 redrawing stages, 3 stages. Write down. Write down. Process of drawing already drawn cup is called redrawing. It's called redrawing. Well, stop. Deeper cups can be produced Deeper cups can be produced by redrawing operation. Let's start. If the draw ratio between the two redrawing stages between the two redrawing stages close to LDR, step rings will appear. Step rings will appear in the drawn component. Step rings will appear in the drawn component. See, because there is a thickening in the wall, and I want to have uniform wall thickness, then the process is called ironing. Ironing is performed in the last stage before we get the final cup. There is a clearance. Clearance is approximately 1.2 times T, 1.2 times the thickness approximately. So in the ironing, what we do, we decrease this clearance. We decrease the clearance to approximately 0.9 times the T. Decrease the clearance approximately 0.9 times the T. So when the cup is coming in, there will be plastic deformation over the wall. This will make the wall thickness uniform. But in the excessive ironing, you will get shiny surface. Surface appears to be bright. Why? Because of residual stresses. So this defect is called burnishing. The surfaces are shiny. Why is it shiny? Because of excessive residual stresses. Burnishing appears due to ironing. 1 or 2 sentences. The process of making the thickness of cup Process of making thickness of cup uniform is called ironing. It's called ironing. And it is accomplished and it is accomplished by decreasing the clearance between the punch and die. Clearance between punch and die. Full stop. As the cup is drawing inside the die, drawing inside the die, there will be plastic deformation over the cup wall. There will be plastic deformation on the cup wall. Full stop. Excessive ironing produces shiny surface and this defect is called burnishing. This defect is called burnishing. Now, how exactly we quantify the formability? How exactly we quantify the formability? One is called Ericsson cup test. Ericsson cup test. It is also called cupping test. It is also called cupping test. So, there is one sheet and the sheet is fixed like this. And a ball penetrates the sheet. Ball penetrates the sheet. So the sheet will deform. Sheet deforms like this. And there is a knacking. Knacking means slight line is appearing on the surface just before fracture. Just before fracture, that is called knacking. So just before knacking, how much is this distance? Is called emitting dome height. And the limiting dome height is the measure of formability. Limiting dome height is the measure of formability. Higher is the limiting dome height, better will be the formability. Second way to quantify this formability is the formability limit diagram. Formability limit diagram. What we do actually, on sheet, I draw number of circles. Okay? I draw number of circles on the sheet. Now, by using a hemispherical punch, I am deforming the sheet. This is called stretching. When I draw the sheet from all the directions, this was the original circle. The circle may deform into ellipse. Circle may deform into ellipse. This is the major axis of ellipse. This is called major strain. And this is called minor strain. Now what we do, we plot a graph. X-axis is the minor strain and y-axis is the major strain. And the graph comes out like this. Below this graph, there are good specimens, and here is a fractured one, fractured specimen. Of course, there are many ways to quantify formability, but these two are very popular: Ericsson cup test and the formability limit diagram. I will not dictate in this thing. You just copy. Copying is very, very important because message gets imprinted in your mind. Hmm. Okay. Whenever you are finished, you write something on your own, 1 or 2 sentences. Once you are finished, please let me know. Once you are finished, let me know in the chat box. Once you are finished, let me know in the chat box. Okay, Anshuman and Vinod. Now, let us see the defects in deep drawing. Wrinkling we have seen. Fracture also we have seen. Step rings also we have seen. Correct, na? Now see draw marks. Look at figure number 4. Look at figure number 4. Figure number 4. So these draw marks, two minutes you look at me. In deep drawing, we need 3 action press. In deep drawing, we need 3 action press. First action for the punch to draw the material. Second action for the blank holder. And third action for stripper plate. And now, what is the function of stripper plate? In deep drawing, my punch should be as rough as possible, and the die should be as smooth as possible. You know why the punch should be rough? If the punch is smooth, when the punch is applying the load, sheet may displace, and after drawing, cup may be in this shape. So if the punch is rough, it will grip the sheet metal. But if the die is rough, when the sheet is drawing into the die, some scratches will appear on the drawn cup. That is called draw mark. Draw mark means my die is rough. So after drawing, this cup will stick to the punch. How it will come out? When the punch is going back, there is a stripper plate to remove the cup from the punch. A stripper plate removes the cup from the punch. I think most of you studying these things first time, correct, na? Write down one sentence. First of all, you copy. 1 minute, I will be silent. Because you are studying first time, please be careful a little bit. Please be careful a little bit. Write down. If die surface is rough, die surface is rough, scratches will appear on the drawn curve. Full stop. The purpose of stripper plate is to remove the drawn curve from the punch. To remove the drawn curve from the punch. Now, see the defect number 5. Orange peel. See the defect number 5 in the photograph. Defect number 5 in the photograph. If my workpiece, the sheet, is having coarse grain structure, generally die is much harder than the work. Maybe after a few lakhs, Anshuman, after a few lakhs, then we have to smoothen the die again. We coat with different material. Okay. So if the sheet is having coarse grain structure, wherever the deformation is more, you will get a very coarse, where you will get a very rough surface. For example, orange you are peeling, na? Orange peel inside surface. Similar surface you look at, looks like. So orange peel defect. So punch corner region only, you will get orange peel defect. So how to avoid it? Use the fine grain structure sheets. Right on? Right on? Right on? If the workpiece is having coarse grain structure, coarse grained structure, comma, wherever the deformation is more, wherever the deformation is more, deformation is more, he will get very rough surface. He will get a very rough surface. Okay. Now, defect number 6, heavy scratches. Heavy scratches. Defect number 6. These heavy scratches will appear and the yield point phenomena appears in the material. Heavy scratches you will get when yield point phenomena appears in the work material. When the yield point phenomena appears in the work material. Keep on writing on your own. Keep on writing on your own. This miss strike defect number 9. When will it appear? And the sheet is not placed symmetrically over the die. And the sheet is not placed symmetrically over die. You have to write in a notebook. Otherwise, things will not enter into your brain. An earring is because of defect number 10, because of anisotropy delta R that I told you day before yesterday, I think. Day before yesterday, I told you all these things. Giving you 1 minute so that you can complete it. Giving you 1 minute so that you can complete it. Okay? You write something on your own so that you are comfortable. So that you are comfortable. Now, one question. It's a IES PYQ mains 20 marks. Mains 20 marks. And this question I have given in my book. A cup is drawn to 50 millimeter diameter and 40 millimeter height. Reduction ratio in first and the subsequent stages is 40% and 50% respectively. How many number of draws are required? How many number of draws are required? 1 minute you digest this problem. 1 minute you digest this problem. Yeah, Radha. Okay, see, this is converted into this D. If thickness given, you can use volume, I don't care, but it will take some time. So you can find out D. Okay, na? Now, overall draw ratio D by D. This D comes out to 51.23. So 51.23 divided by 15. This is the overall draw ratio. But this draw ratio cannot be achieved in one go because almost 3.5 na draw ratio. So in the first draw, you are going from D to D1. This D1 becomes the blank size for the second draw and D2. D2 becomes the blank size for third draw and so on. And it should be equal to the overall draw ratio. In the first stage, there is a 40% reduction, meaning D1 will be 0.6 D, correct? 40% reduction. And subsequent draw means second, third, fourth, fifth. There is a 15% reduction means D2 is 0.85 D1, D3 is 0.85 D2, and so on. 15% reduction in subsequent draws. Put it here. D divided by 0.6 D, D1 divided by 0.85 D1, D2 divided by 0.85 D2, and so on, should be equal to 51.23 divided by 15. Let us say there are n stages. N stages 1, n minus 1. Because in the n minus 1, this quantity is uniform. So 1 by 0.6 into 1 by 0.85 raised to power n minus 1 is equals to, find out n. What is n? Yeah, 5.4, it means 6 stages only, because even for 0.4, we have to have another draw. Okay, that was your deep drawing. That was your deep drawing. Next is a bending. Bending. Bending of different types. Suppose my die is like this. Okay. And the sheet is like this. And punch in this form. It will come out in the V form. It is called V bending. Then heat and punch is also like this. It's called U bending. This is a die. Sheet is like this. Hold the sheet like this. Apply force. It is called edge bending. The moment you remove the load, it will unbend little bit. It will unbend little bit. And this is called a spring back. Okay, now just copy quickly. There is no. In my book now, I have given lot of variety of definitions. Go through once. If you have my book, please go through once. Please go through once. Okay. Let us see the age bending. My dear students, I am covering only the gate specific things. Okay. There are some details in it. I am not going through it. Okay. This dot I. Okay, I have applied the load here. After spring back, situation is like this. After spring back, before this line, sheet is straight. After this line, sheet is straight. And this is the bend region. This theta is called bend angle. And let us say R is the bend radius. Now, in this edge bending, we defined something called bend allowance. The term bend allowance is slightly different here. The term bend allowance is slightly different here. Bend allowance is length of neutral plane in the bend region. This AB is the bend allowance. AB is the bend allowance. Diameter is 15, height is 40. This is 40, this is 50. So, what is the bend allowance? Length of neutral plane in the bend region, and it is nothing but R plus KT into theta. R is the bend radius, T is the sheet thickness, theta is the bend angle. K is called stretch factor. Based on this, there are many questions in GATE. Stretch factor is 0.33 when R is less than equal to 2T. And it is nothing but 0.5 when R is greater than equal to 2T. So when nothing is given, by default take it at 0.5. Take stretch factor is 0.5 when nothing is given to you. And it is not 240, it is and 40 millimeter. 15 millimeter dia and 40 millimeter height. Okay, na? Parvaledu. Based on this question, there are many questions in Moni Ratan is very attentive actually. This boy is also very brilliant. He's a very attentive. Now, is force in bending in deep drawing also we use empirical formula. And if the deep drawing force is required, the empirical formula will be given to you. It is nothing but F is nothing but C1B T square sigma naught by L. Sigma naught we know very well. T is the sheet thickness. T1 is 1.33. It's a constant. B is called bend line length. Bend line length. And L is called die shoulder length. And when nothing is given, take it as a 80. This formula you have to mug up if you are preparing for IES, otherwise leave it. This formula is very important for GATE. Okay? Bending. No problem, no problem. No need to say sorry. Once you finish, you tell me. Once you finish, you please tell me. What is the bend allowance? It's the length of neutral plane in the bend region. Okay? Once you are finished, please let me know. Okay. Just a minute. I am waiting for others because some of you. Oh, okay, Prashant. These young people are really too good actually. It's a feature of India actually. Correct, na? Suryavanshi and Jaiswal. Okay. Suppose this is the sheet. This is the sheet. Okay, na? If you share the sheet like this and leave it, share the sheet like this and leave it, it is called lensing. And from one corner, if you remove the sheet completely for some time, for a small portion, if you remove completely, it's called notching. I will give you time. You write on your own words, notching and lensing. You can write in your own language also. What all of you feel? I am saying correctly, na? There are two young people, Suryavanshi and Jaswal, very good feature of India actually. See, they are playing a spirit. Too good actually. Too good. And one is 14 years old, another is I think 19, 20 years old. Youngsters. Okay, write in your own words. All right. Notching and lensing. Then, if you make multiple hole in the sheet, it is called perforating. See, you have to write on your own words, in your own words. Acha, Prashant. From one side, if you remove the material completely, it is called notching. Notching. In Hindi, notch ke फेंक दिया. But if you shear off and leave the material like this, it is called lancing. I'm waiting. I'm waiting. Understood, Prashant? I'm waiting. And what is perforating? Making number of holes in the sheet. Making number of holes in the sheet. Now, correct? Everybody's writing now. This is a sheet. If you tear off the material from middle and leave it like this, it is called slitting. Slitting. But when you completely remove the material like this, when you completely remove the material like this, it is called parting off. Right, right, right. Splitting and parting off. Splitting and parting off. Right, one sentence. You can write in your own language also. You can write in your own language also. That will be easier for you. Okay. Okay. Now, parting off. Parting off is remove the sheet completely like this. Parting off. Splitting is split like those who are meat eaters, na? Splitting is halal. Parting off is jhatka. Anyway, most of you South India, you cannot understand these things. Those who are in North India, they can understand these terms very well. I am a vegetarian. Okay, strict vegetarian. Okay? Now, imagine a situation what exactly happened in the door of my house, na? We have hanged one flower plot actually. Okay, na? One bird, very small black bird, he laid egg in that actually, and she is troubling us a lot actually for hitting the head. I don't want to remove because the bird may be confused. Actually, suppose if I want to remove and hang somewhere, bird may be confused. Where is my egg? So anyway, last 4 or 5 days I was struggling actually what to do. I didn't want to harm that bird also. Suppose there is a bread, huh? Big piece of bread lying on the table. In the night, one mouse comes. So mouse will eat the bread and the mouse will create a path. Mouse will create a path in the bread. Similarly, you take a very small punch and die assembly and remove the material in a small quantity like this. So you can create a path. A profile by a small punch and die assembly, cut the material into along a path is called nibbing or nibbling. Nibbing or nibbling, both are same. Nibbing or nibbling, both are same. Write down this. I will dictate. Nibbing or nibbling. It's a process of cutting the material along a path. Cutting the material along a path by a small punch and die assembly. By a small punch and die assembly. Okay. Now, high energy rate of forming. So, types of dies. One is called simple die. Write one line definition of simple die. Write one line there are three types of dies. Write one line definition of simple die. When one operation is performed on one station in a single stroke, It is called simple die. It is called simple die. Second is a compound die. Actually, in Telegram, some students are asking very, very simple questions actually. I am in the class. If you have time, you can answer how ductility with a stress resistant diagram, how it is measured actually. Anyway, right on compound die. On a single station, on a single station, comma, in a single stroke, in a single stroke, when multiple operations are performed, when multiple operations are performed, it is called compound die. See, suppose this is a die. This is the sheet. Punch is in this form, see. This is the punch. So when this portion of material hits it, this is the waste. So it's a punching operation, correct? Now punch continues to move down, and when this portion shares of the material this is useful, means blanking operation. So in same stroke, same station, punching and blanking both are performed simultaneously. It's a washer manufacturing, washer. It's a washer manufacturing. So in the one stroke when blanking and punching both are performed, it's a compounding die operation. Now understand? Giving you 1 minute. Okay, na? Once you are over, please let me know. Okay. Now, there is something called progressive die. Progressive die, one definition, write down one line definition, progressive die. Progressive die, also write down one line definition. In a single stroke, write down, in a single stroke, multiple operations are performed. Multiple operations are performed on multiple stations. On multiple stations. What is this? These dies are very large. These dies are very large. Runs in crores. Runs in crores. Runs in crores actually, these dies. So there are multiple stations. First station, second station, third station. And there is a RAM. And on the RAM, there are multiple punches. So multiple punches for multiple stations. In one go, multiple operations will be performed. See, there is something called hybrid die. Hybrid die is not a separate category of die. One station, suppose there is a compounding operation. Compounding operation, that progressive die is called a hybrid die. I answered this, na? Either punching or blanking, tensing, notching, perforating, parting, nibbing, multiple operation, deep drawing, stretching, redrawing, many operations are possible. At least there are 35 different sheet metal forming operations. At least there are 35 different sheet metal forming operations. Giving you 1 minute time so that you can Okay? Babu, I hope your question is answered. I hope your question is answered. Now, last topic of metal forming is high energy rate of forming. High energy rate of forming. High energy rate of forming, as I told you in the material science, when the rate of deformations are quite high, elastic regions disappears. I mean, the curve shift and material behaves rigid plastic, very high strain rate. Because there is no elastic region, because there is no elastic region, so no spring back. So we will get very accurate products formed. We'll get very accurate products formed. That's the beauty of high energy rate of forming. Now there are different types of high energy rate of forming. One is explosive forming. Explosive forming. In explosive forming, there is one container, and this is the die. And over the die, there is a sheet. And there is some fluid, generally water. Fluid, generally water. Generally. And here, there is an explosive. Generally TNT. TNT means trinitrotoluene. TNT means trinitrotoluene. So when we blast, high pressure wave will form in water that forces the material over the die. Of course, in a high energy rate of forming, there will be damage to die. Operational cost is high and the die life is less, but still we go for it because accuracy. Now, the intensity will be controlled by the quantity of the explosive that we are exploding. Dynamite is a weak explosive. That also we can use it, but generally we use TNT. Dynamite is TNG, trinitroglycerine. Trinitrotoluene is called RDX. Trinitrotoluene. It's a much more, all these bombs, India Pakistan war recent, most of them was basically TNT. Okay, na? In the India, Pakistan, have you seen this thing? T and most of them are TNT and RDX. I want to dictate 2, 3 sentences here. Write down. The most important advantage the most important advantage of high energy rate of forming is accuracy. Prashant, that's the reason I'm dictating. Is accuracy. Is accuracy. Because at a very high strain rate, at a very high strain rate, there is no elastic region. There is no elastic region. Oh. So no spring back. Prashant, is that okay for you? So no spring back. Please stop. By exploding TNT in water, I know that when we write, understanding becomes much more clear, Prashant. I know that actually. So that is the reason very, very important stuff I dictate. Because when we write, things become very, very clear. First here, then write. Okay. By exploding TNT in water, a high pressure wave will form. A high pressure wave will form that forces the sheet over the die. That forces the sheet over the die. Full stop. Intensity of pressure wave intensity of pressure wave depends upon the quantity of explosive. Second is the electrohydraulic forming. What is electrohydraulic forming? This is the die. This is the sheet. And the medium here is a dielectric. Means either kerosene or deionized water. Similarly, the way we do it in EDM process, EDM, exactly same. So there are two electrodes. And these electrodes are connected to an RC circuit. This it's a battery bank. It's a similar to that of EDM, exactly similar to that of EDM. So when there is a discharge, current will flow for a very short period of time, and during the discharge, a high pressure wave will form in the dielectric that forces the metal over the die. The principle of operation is similar to electrode discharge machining. Exactly similar. I think manufacturing part 1 is not done for you. That is the reason you may not understand this one. But once it is done, I think it will be crystal clear. Okay. Copy. I will dictate one sentence here also. Okay, write down. Write down. Two electrodes are connected. Electrodes are connected with an RC circuit. With an RC circuit. Comma. The moment there is a discharge. The moment there is a discharge, a high pressure wave forms inside the dielectric. That forces the material over the die. Then electromagnetic forming. Electromagnetic forming is slightly different. This is a die. And over the die, I have kept one sheet. And at the top, there is a coil. And by supplying current, the coil will develop its own magnetic field. We are also supplying current. We are also supplying current to the workpiece. So workpiece will develop its own magnetic field. Now these two magnetic fields will repel each other. That forces the material over the die. Generally, for forming thin tubes, we use this process. Here, the sheet is the work material. Na? The work material need not to be magnetic, because how the magnetism I am introducing? By supplying current. So the work material should be conducting, need not to be magnetic. Anyway, the top person in all over the world, there we have, India has got very good researchers actually. My friend, Professor S.D. Kore, is the top person, especially in the electromagnetic forming. He was an IIT Guwahati, then he went to IIT Goa, and presently he is the director of one big institute in Maharashtra, Jijabai University, something, Jijabai Institute. He's a director, Professor S.D. Kore. He's champion in this. You can say world #1 scientist, especially in this. Okay, write down here, write down. Write down. Oh. One coil is kept over the workpiece. One coil is kept over the workpiece. And by passing current through it, it develops its own magnetic field. It develops its own magnetic field. Develops its own magnetic field. Full stop. Current is also supplied to the work. Current is also supplied to the work. Current is also supplied to the work. Due to which it develops its own magnetic field. Due to which it develops its own magnetic field. Full stop. These two magnetic fields oppose to each other. These two magnetic fields oppose to each other. Oppose to each other. That forces the material. That forces the material over the die. Forces the material over the die. Full stop. Workpiece here need not to be conducting. Workpiece here need not to be conducting. So need not to be magnetic. Sorry, I'm sorry. Workpiece here need not to be magnetic. Need not to be here magnetic, but it should be conducting. But it should be conducting. So, dear students, of course, for IES, there are some other details. Powder metallurgy, I don't want to do it today because I want to finish the forming questions also. And I'm teaching metallurgy. Tomorrow I will start metallurgy. So I will stitch and edit this additive manufacturing. Other teacher takes. He's a BTech in from IIT Delhi, and he was also my student actually. Other manufacturing teacher, because there are multiple batches, so it's a big syllabus. The production industrial we share. Okay, nice person actually. So powder metallurgy and a Jigsaw fixture, I will stitch in while teaching metallurgy. Okay, na? So I want to do finish off questions. So metal forming, class, I pen the. It's a big topic. Metal forming, you can say it's a biggest topic in production. Okay. I want everybody should use poll. Give me the answer of this. Give me the answer of this. It's an easy one. I am sure you can hit it. Think over it deeply. Think over it deeply. Think, but yeah, whatever questions we are doing, please use your intelligence. I have taught you all theory. Please use it. Intelligence. And I'm sure most of you can hit it. I'm sure most of you can hit it. Hearing. It will be independent of the speed of press. Rest, tank holding pressure is less. It may lead to not only earring, but also wrinkling. Clearance between the tools, because when there is a too much plastic deformation, that also may produce ears. 25%. Only one person. I think Jayant. Nobody even tried actually. Only Jayant. Three more people are tried, but that is wrong. 90 seconds. 90 seconds only. 90 seconds only. Hare Prashant, that is a that is a 100% correct. Planking die is exact, and it is saying clearance must be given to die, so it's a wrong statement. Punching punch is exact. Planking die is exact. Please remember this thing. 66%. Babu, Monitharan, Prashant, Jayan. Good. 100% should come answer. This you have to mug up. It is basically IES thing. Anyway, this get you should ignore this question. I was thinking to delete it, but somehow. Okay. Please be careful. It's a self-explanatory. self-explanatory, everything. Okay. Oh, 100%. Good. Magnetic forming is an high energy rate of forming process, correct? These are questions actually appeared in examinations. Which of the following metal forming process is not a high energy rate forming? Roll forming is not a high energy rate of forming. Correct? Let's repeat. Repeat question. Can you read this? Drawing force, you can use this formula. Phi dt 2ts d by d minus 0.7. This is IS specific question. H is here. Oh, starting blank diameter is 150. Drawing ratio is 152 by 80. Percentage reduction you can calculate. D minus D divided by D into 100. D is the original blank diameter drawing force. And the blank holding force, blank holding pressure will be 2% of the yield strength, means 0.02 into yield strength is how much? 180. Now force will be blank holding pressure into pi by 4 d square minus d square. Correct? Because only on this ring only it is applying pressure. Na? All of you should do it. All of you should do it because you will get a practice. Calculate all the answers. Moniratan, you have to give me the answers. All the 4 answers you have to give, Moniratan. All answers, you should write it down. All answers. I want all of you to do calculations. Huh? All the value you should give me. Blank holding force, how much? Yeah, 45.5 kilonewton. 45.5 kilonewton. Because when we do this calculation, na, we will understand it better. We will understand it better. See, this question, it's a very equating the volume. 4.44 inch. I don't want you to basically bang your head here. It's a IES specific question. Equate volume. Equate volume. Answer will be 4.44. I don't want to bang your hand. Those who are gate specific, I don't want you to bang here. But if you have time, just go through it. But I want you to calculate this answer of this question. Do it. We'll solve the answer of this question. I need the answer of this question. LDR is nothing but e raised to power eta beta. Efficiency is not given, so eta is 1. Beta is under root r plus 1 by 2. And r is width strain over thickness strain. Length direction, LF is 1.23 Li, correct? And TF is nothing but 0.9, correct? So epsilon L is nothing but ln LF by Li, means ln 1.23, and thickness is nothing but ln TF by Ti, means ln 0.9. Okay. Now volume is constant. LWT is nothing but volume, correct? Take log and then differentiate. You will get dl by L plus dw by W plus dt by T is equals to 0, or length strain plus width strain or thickness strain 0. This is the length strain, thickness strain. You will get width strain from here. Okay, na? Calculate R, put it here. I need the LDR value. Do it. I need LDR value. Please do it. I need the answer. When you do calculation, na, you will understand in a better way. No, 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 Manrathan. I think you were in the rush. That is not correct answer. Please try with a cool head. I want correct answer. Babu, can you please remember whatever I told you in a personal Telegram chat yesterday? Okay, no, you are a very good boy. I'm telling you. If you can manage that, na, you will be under 100 rank. I'm telling you. Your calculations are too accurate. But don't get too much disturbed. Whatever I see my personal message on a Telegram. You are a ranker if you can manage that one. Okay, now also one more thing actually I want to add. Don't get angry on the people, because by that once you are angry on one person, na, you try to shift the anger on others. Please control it. How to do it? Remember whoever God you believe in. Please remember him. You are a ranker actually. There are 2-3 rankers are there actually here. I already told their names actually. There are 2-3 rankers in this batch. If they can manage the cool head. Cool head. Yeah, you are correct. It's a 2.69. You are 100% correct. 2.69. Yeah, Lakshmi, very good. I'm serious in this English batch, although strength is less, but there are rankers here. There are rankers here. 100% there are rankers. Whatever spiritual activity do, morning hours, you please do it 15-20 minutes. Have a cool head. And do well. Yeah, what is the question? This is a little complicated one. I want you to read it. I want you to read this question. I will tell you how to solve it. I will tell you how to solve it. Read the question first. 2 minutes. Read the question. It's a very good question. Initial length is how much? 250 plus 500 is 400. Initial length is 400. And what is final length? 441.4. 441.4. So epsilon will be ln LF by Li. And I will give you what is the answer basically here. 0.098. 0.098. Okay, na? Total work done ignoring the end effects and bending. So, total work done is nothing but integral 0 to epsilon sigma f d epsilon. Okay, na? So, integral 0 to 0.098 700 epsilon is to power 0.3 d epsilon. Do it, do it, do it, do it. It is a work done per unit volume. This is nothing but work done per unit volume. So you can calculate U, and work done will be nothing but U into volume of material. Can you give me what is the value of work done? I have the answer of this one in Newton meters. In Newton meters, I have the answer. Newton meters, I need answer. 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 Arey, what is the answer? I have the answer for this question. Arey, volume dimension, your arm? Length is 400 mm and area is 300 mm square. Work done. That was slight miscalculation, I think. Answer should be 3153.6. This should be the calculation. The way we are calculating some of the quantities, it's very, very important to learn. The way we are calculating some of these quantities, yeah, Babu, yeah, correct, yeah, correct. Or 3.15, we can say kilonewton meter. Okay, that we can do. 1,000 factor you have missed somewhere previously. Now it's correct. Others should also give me the answer. Okay. All right. The second part of the question is, what is the alpha max before necking begins? So at necking, n is equals to epsilon, and it is 0.3. So 0.3 is nothing but ln LF by 400. So at necking, I would like to know how much is the final length. So from here, LF will be that I have the answer for this thing. 540. Yeah. So my triangle is here. This is the 400. A, B. A plus B is 540. Calculate this alpha max by geometry. And that alpha max will be 35.6 degree. 35.6 degree. Just note it down. The procedure you should know. Procedure you should know. Procedure you should know. Do copy? Okay. Can you give me the answer of this? Answer in poll. Okay. D. 83%. Good. What about this? Only 90 seconds. It was self-explanatory. Do in poll only. Yeah. So again D. These are easy things, easy bits. 80%, very good. Only 5 people attempted it. Arre, okay. Can you solve this? Give me the answer of this. It's very easy. Give me answer in chat box. Okay. LDR is 2.68. So d by d is nothing but 2.68. Correct? Pi by 4 d square is nothing but pi by 4 d square plus pi dh. Pi cancels out. Multiplied by 4, pi by 4, you can say 1 by 4 d square minus d square is equals to dh. Now, divide by small d square. So, d by d square minus 1 is equals to 4 h by d. D by d is 2.67. 0.67 square minus 1 is equals to 4 h by d. 1.55. Easy, anyway. Very good. Very good. Hmm. Everybody should understand it actually. Everybody should understand. There is a lot of variety in the workbook. Lot of variety in the workbook. Mhm. Normal anisotropy R bar R0 plus twice R45 plus R90 divided by 4. Planar anisotropy is delta R is equals to R0 minus twice R45 plus R90 divided by 2. I explained these things na, 2 lectures back. 2 lectures back. Normal and planar anisotropies. Huh? I think this is the repeat question. Huh? Yeah, it's a repeat question. Now, forging workbook. We will mostly there are theoretical questions here. So please answer in poll only. Poll only. Mostly theoretical question. And I'm sure most of you can do it. Forging is generally done at room temperature. So among all the forging, normally forging is done at room temperature. So there will be improved physical properties. Generally in the forging, we will get a higher mechanical strength. Anyway, it was a ES specific 62% student got it correct. Okay. All right. Yeah, can you give me the answer of this? If you have attended the theory classes of mine, answers are easy. No, 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 Babu, that is not correct actually. Compared to other. Uh, Please take these problems very seriously, forging problem, because we have done 4 days back. In drop forging, beside the provision for flash, provision is also to be made in the forging die for additional space called gutter. Correct? It's a correct statement, na? The gutter helps to restrict the outer flow of metal, thereby helping to fill the thin ribs bases in the upper die. Because well-developed sill plans are there. %83, very good. Yes, we have done it. Which of the following process is most commonly used for forging a bolt heads of hexagonal shape? See, we cannot do in the open die forging, because open die forging hexagonal shape will not come. Drop forging, there are chances of surface cracks, so we do it by press forging. Understood how to basically put the logic? This sequence is 1, 2, 3, 4 only. You just mug up. It's IES specific. Flattening means, suppose there is a distortion in the material, tuck, 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 make the sheet flat. Then upsetting. Upsetting means forging a portion over, wedging, and then cambering. Cambering means, what is the cambering? This is the called na chamfering little bit. It's called cambering, and that is done in the last bolt. There's a sequence in which the process goes. Cambering the last, it's a finishing operation. It's a finishing operation. This also, please remember, this also, it's a ES specific question. Now here the thing is, we do finishing last and the trimming last. After finishing also, whatever burrs are there, if we remove them, that is called trim. As per the understanding, B is the correct answer, because what is the blocking? Aging process is the blocking process, you can say. Okay, no? It's a blocking top process. Basically, put the raw material and put it in, in some shape initially. Anyway, this you just leave it. It's not for gate. This question is not for gate. Can you give me the answer of this? It's an easy one. So I'm eliminating some of the ESS specific questions from you. Okay. This is the definition of fullering. Correct. This is the definition of fullering, whatever is written. Yeah, what about this? Yeah, finally, by which the flesh is in the gutter, the process of cutting is called trimming. It is, yeah, this would be correct actually. Why there is a wrong for some of the students? You write down because options are on the next page. You write down this thing because I want you to basically solve this question. A is a drop forging, B is a press forging, C is a upset forging, and D is a roll forging. A is drop forging, B is press forging, C is upset forging, D is roll forging. You have written, na? Now, give me answer. Match the following. Do it. I want you to solve this. Huh? It's a C. %20%. It was easier stuff. Lakshmi's answer is correct. It was easier stuff actually. Some of you got it wrong actually. Write down. But this they have also put into the two sheets. Number 1 is a Smith forging, B is drop forging, C is press forging, and D is machine forging. Write down, write down. Because the options are on the next page. Smith forging, drop forging, press forging, and machine forging. Okay, ready? Okay. Now, what is the answer? Everything I have taught you. Yeah, answer is A. Do these things by the process of elimination. Now this is correct. Correct. Such type of questions, do it by the process of elimination. Okay, now give me the answer of this. Be little thoughtful. Be little thoughtful. Okay. See, the question is cold forging results in improved quality due to which of the following? Improved quality. In that high pressure, of course, in cold forging, high pressure comes, but that is not the reason of improved quality, na? There was a little trick here. I'm sure some of you must have got it wrong. 37% only. There is a high pressure, but that doesn't mean that there is an improved quality because of that. This we have solved in class. Okay. Yeah. Can you give me the answer of this? It's a very good question. Give me the answer of this. It's a very good question. Okay. In an open die forging, a circular disc is gradually compressed between two flat platens. The exponential decay of normal stresses on the flat face of the disc from the center of the disc towards the outer periphery. In case of sticking, that sticking region will have a linear decay, but everywhere it's an exponential decay. It indicates that there is no sticking. By the way, this is the PYQ. If there is a sticking, there will be linear in that portion. Na? Let us see who got it correct. 25%, only two people. Babu, 10 correct out of 13. Jayant, 9 out of 13. Monarathan. Okay, no problem, no problem. No problem. It's a MSQ. Yeah. Multiple select question. More than one answers are correct. More than one answers are correct. More than one answers are correct. More than one options are correct. See, all four are correct. Let us see. 100% correct answer is only for Babu. He has selected all four. Other percentages is given here. Now, this next four question, think over it before putting the answer. I have taught you everything. I have taught you everything. Both dies are made in pairs. The material is pressed between the two surfaces and the compression force applied gives it a shape. If it is not made in pairs, the shape will not come. What kind of defect will appear? Die shift. So that is the correct reason, because shape will appear, correct shape will appear only when the upper portion and lower portions are matching. Percent. Always made in pairs. I told you in the class. It is difficult to maintain close tolerances in the normal forging operation. That is a correct statement. What is the reason for that? Let us say forged component is inside the die. So, of course, most of the time you are doing the cold forging, but because of cold working, also crystals are breaking, some temperature, any rise will anyway happen. So after forging, when the temperature comes to room temperature, it will shrink a little bit. It is easy to take out of from the die. But what is the reason a statement forging is workable for simple shape? That is also correct, because it's not a liquid metal. Na? So if it's a very complex geometry, metal may not flow. Of course, we can give the gutter, some slip lines form, but still very complex shape cannot be formed. So best answer here is a B. Very good. Uh, so in high velocity forming process, high energy can be transferred to metal with a relatively small weight. That is correct. A high energy rate of forming. Okay, na? So with a fraction of movement, we are supplying lot of energy. Like high energy rate of forming principle. Constant energy is the function of mass and velocity. This everybody knows, na? Half mv square. But high energy rate of forming, why we do it basically? Because suddenly when the energy is supplied, there is no elastic region. That's the reason we use a high velocity forming process. So both are correct, but it is not the correct explanation. Can you give me this answer? Easy, but let us see if you can give me the answer correctly. Easy. Let us see if you can give me answer correctly. In power forging, energy is provided by compressed air, oil, pressure. That's correct. Along with gravity. Along with gravity. The capacity of the hammer is given by the total weight. No, it's not a total weight. It is given by the oil pressure. Or gravity means partially gravity. Aman. Anyway, we have finished metal forming. Finished metal forming. Tomorrow, we will start a fresh topic called metrology. And what I request to all of you is read normal distribution before coming to evening 7 o'clock class. Study normal distribution. If the mathematics it is not covered, study from Khajana before coming to evening class. Thank you very much. Good evening to all. Thank you very much. See you tomorrow at 7 o'clock.